Okay, so as we begin to review for our diploma, looking at thermochem, I just wanted to focus on bomb calorimetry for a moment. So bomb calorimetry is not something you see as much as regular calorimetry, but just starting off with the first few assumptions when you do have regular calorimetry, and will change with bombs. So just going over it, the first one, no heat's transferred between the calorimeter and the outside environment because we're assuming it's an isolated system. Number two is the biggest one here. Heat absorbed or lost by the calorimeter is negligible. So this is an assumption for regular calorimetry, but with bomb calorimetry, this changes a little bit. And this is the last one, number three, your diluted aqueous solutions have the same physical property as pure water. So saying that the specific heat capacity is 4.19 joules per gram degree Celsius. This matters if you're mixing an acid with a base, but that's not happening with our bomb calorimetry. So in bomb calorimetry, because you are dealing with combustion reactions give off a lot of heat. And in that case, the container can absorb that heat and it will need to be accounted for. So to do that, you stick with the regular part of the formula. That's not changing. The information about the reaction, so N times H, will equal negative MC delta T, and that's all about the water. But now we're adding on this second part, and this is about the container. So now we need the mass of the container, the specific heat capacity of the container. If that is not given to you, you can find it in your data booklet, and the temperature change of the container. And again, if this is not given to you, with this being our system, we could often imply that delta T is the same for each, unless other information was given to us. So I have two diploma questions. One is the theory question, and the second is essentially the same question, but just with numbers. So here we have ethanol, and it some information about it, and then it tells you we're going to find the molar enthalpy of combustion of ethanol. So the fact that it says combustion, we are implying bomb calorimetry. The bigger indication here is that we have an aluminum container. So now we have a container that can also absorb heat. So we have the formula NH equals negative MC delta T plus negative MC delta T. So again, this part here is about the reaction. In this case, it would be the reaction of ethanol, so C2H5OH. This first part will be water, and the last part of our equation will be about the container, and our container is aluminum. So going through this, number one, saying the maximum temperature change of water. Saying temperature change is implying you have all of delta T, final and initial. So that's good, we have that. And as mentioned, we can say that that is the same as the delta T of the container. Then moving on from here, saying the mass of the aluminum container, well, that's perfect because we need that. Number three, mass of aluminum container and water. So just over here, hopefully this will make sense. If you have the mass of the water and the mass of the container, which that's what number three is saying, which shows us a total, so the two together. If you take away the container from the total, you will have the mass of water. So then we would have this missing variable here. Number four, initial temperature of the aluminum calorimeter. So we might think we need this because delta T will equal final minus initial, but saying initial temperature, that's just giving you I. So we wouldn't know F, which means we don't know delta T. So that's not helping us too much unless they gave us the final temperature somewhere else. Number five, maximum temperature change of ethanol. Ethanol has to do with the reaction. We're not measuring the temperature change of this. We're measuring the temperature change of water and the temperature change of the container, but not ethanol. And then the last one, the mass change of ethanol. We do want that because as we know, if we have mass in grams and you multiply by your mole ratio, so we'll put 1 mole on top per grams cancel, and now you have moles. So here, what's useful for us to solve would be 1, 2, 3, and 6. And that's implying that we do know the specific heat capacity of the water and of the container. So we would know this because it's in our data booklet. Now, using that same theory, but now with numbers, we're doing the same thing, just plugging it in and showing how we can figure it out. So we want the molar mass of combustion, so that is implying bomb calorimetry. We also have an aluminum calorimeter, so we do know we're using bomb calorimetry. So you're starting off with that same formula, NH equals negative MC delta T plus negative MC delta T. So let's start with that information about water, which would be the first bit. And the mass of the water, we don't have yet, but we have the mass of calorimeter and water together, and we have the mass of the calorimeter by itself. So if we take the mass of the calorimeter away from the total, we'd have the mass of the water by itself, and we can say it's in grams. We know the specific heat capacity of water, and this information here, if you take final and subtract your initial, you'll have the temperature change of the system. Now, for your container, we're given the mass, 43.35 grams. We also can find, so this is just a snapshot of, I believe it's page 3, but it's a page in your data booklet to show that you do have the specific heat capacity available to you. So joules per gram degree Celsius. And because we don't have a temperature change of the container itself, we can assume it's the same as the temperature change of the water. Now with this, you'll notice that your grams cancel, your degree Celsius cancel, but what doesn't cancel is your joules. So our energy is measured in joules to begin with. Now on the left-hand side, again, if we're finding molar enthalpy, our goal is to get H. But we use this last bit of information. If you know the final mass and the initial mass of ethanol, and you do final minus initial, you'll find out the amount of ethanol used in this experiment was 0.62 grams. And if you calculate the molar mass of ethanol, you will get 46.08 grams. So now grams will cancel, and you have your moles. Now, our last step then will be to get H alone. So we'll figure out what this equals, and we'll divide it to the other side. And all this information here, it's one big number. So you can put this into your calculator like you see it. So to get H alone, again, we're going to get that total from the right-hand side, and it is a fairly large number. So 28897.839, and this number is going to keep going. It is in joules, and try not to round too early because it can affect just that little bit at the very end, and sometimes it will matter. And then we're going to divide by, and in my calculator I just did this in a step in brackets, 0.62 grams times 1 mole over 46.08 grams. So we plug this in, and you'll get your enthalpy to equal one large number. So I'm seeing 2.147, and this is a very big number. It's going to keep going, but times 10 to the power 6. So with this, again, with our units, this value of enthalpy is in joules, but it's asking us to have it in scientific notation, but in kilojoules. So to go from joules to kilojoules, you'll take your value and divide it by 1,000. And that will give us 2,147.76. And again, this number keeps going, but now we're in kilojoules. To put this in scientific notation, we'll move the decimal over 3 places. So 2.1. Before we drop this ending, that 7 does bump up that 4 to a 5. So 2.15 times 10 to the power 3, because we moved it over 3 places. And your value is in kilojoules. It is negative because it's combustion, exothermic. It should be negative when we are done. And this negative actually didn't cancel out at any point. So your answer with this one would be 2153, because this would be your A, your B, your C, and your D. As always, I hope you found this helpful. If you did, please subscribe. And if you'd like me to do any other video, just let me know in a comment. Thank you for watching.